everyone, welcome back. Today I'm going to show you a quick and easy way to fix common problem rigger face when working with IK and FK system. I'll address the issue where the joint don't align properly when switching between IK and FK mode. The best part, you don't need to redo your entire rig. Let's dive in. Quick side note, I have an older Bumblebee model that I created back in 2007. If you like to follow along with me, I have three versions: a one rig, a non-rig version if you want to start all over again, and also a car. I'll only send off files to those who request them. So let me know if you're interested. Also, feel free to tell me how you like the tutorial to flow, whether you prefer a slow or faster pace. I know everyone learns at their own speed, so I want to make sure this works for you. Let me know your thoughts. Now let's fix the problem. So we'll start with the translation first. Let's hide the model. This is the rest state that I wanted to inherit. So the best way to do this is go ahead and mark the location. I'll mark it with a locator. And this is the position that I want it to be. You can create a group or locator to mark the rest position of the joint. Ensure the rest position match for both IK and FK. Now if we look to know, we know we have information and also a rotation right in our joints. So let's identify where this constraint is coming from. So we know this is all a skeleton joint. Now we want to verify where our joint. So we know we're dealing with the IK is the one that's problem. So we can go to IK joint, look for the shoulder. If I can find it. There we go. And our shoulder has some information, but this is not the shoulder that we want. We want to make sure we can press up, and until we find the actual parent constraint. So the way we can identify which one that has the parent constraint, so we could go to node editor and we can graph that, and you'll see is the constraint. We'll graph the constraint, and we're looking for the in place, and we know this is the location. So we'll just snap it back. We can verify that by switching between IK and FK. So the translations is fixed. So now we need to fix the rotation. So the rotation will also be in the IK. Pin the shoulder to isolate the rotation issue. Grab the IK shoulder and pin it. Actually, this shoulder. Compare the rotation value in FK and IK mode. IK, FK, it's 0. And when it comes to IK, you'll notice that you have numbers. So to reset the pole vector, we can go ahead and note when we already identified it is going to be in the IK mode and also in the pole vector. So we can take the IK joint and graft it and look for the IK handle. Hit 3. So the information that we're looking for, you'll notice in the joint, it is equal to the exact same number. What can we do? We can try to reset it. Nothing's happening. Now, we can try to do a basic math here by taking the pole vector constraint, we want to reset the pole vector. If we try to reset the pole vector, look at the number here. Everything's at 0. That's pretty good. And if we switch between IK and FK, you would think, okay, we fixed the problem, so everything's good, and we moved on. If you go try to animate or give the rig to someone else, the minute I move a controller and I try to go back, and now it went back to exactly to the state that it went. So we know this is not gonna be the fix. So let's try to multiply and divide. X, Y, Z. We'll go to the input. All right, it still give us the same numbers. So if we know multiply, divide, if you multiply it by 0, you get 0, right? So we can multiply that by 0, and now everything fixed, right? So if we try to move and go back to, everything's still the same and still at 0. But one problem is, when we divide, when we multiply by 0, no matter what number I put into the pole vector, the number will still be 0, no matter what. So how can we tackle this? So let's tackle this by using condition nodes and subtraction. I'm going to create a condition for each coordinate. Duplicate it. True, true, R will be an X, G, Y, and BZ. Okay. Now that we have a condition that channel to all multiplier, again, you don't have to have the multiply divide. You can just plug in straight there. I like to have the multiple divide just so I need to tweak just a little bit, and I can tweak that from there. So this is the number we want. We want it to be at 0 or close to 0. Now we can use a plus and minus to subtract. Oops, no. So 3 plus and minus X Y right. B, when D goes R, let's do G, which is true, and now that we should have some information from our rotation. So if we look here, it's still multiply by 0, so we'll just multiply that by 1. So we start having big numbers now. So now let's do an operation from there. So for the operation we want to use is plus and minus. So we don't have a second slot to. We do have an input 1D, but it's not activate. So we can open the array and just remove it. With that, it gives me a place where I can subtract it from or add it from. So we're gonna do a subtract for all the operation, which operation 1, 2, 2. Subtract that. Just like so. And from here, we want to not equal. So right now, operation 0, I believe. So we don't want it to equal to, and to not equals to the subtraction that we're doing. So it either give us a 0.1 or 0.001, and once it's true, and I want my elbow to move. Right now, if I try to move my elbow, as you can see, it's very, very sluggish, very robotic and snap. So we want it to be smooth. So even if we subtract this by itself, it will give us 0, that's what we want. Everything should be good, but why is this not working the way it should? So if we move or of going from IK to FK, everything's fine. But why is it not working, right? So that's where the little magic comes. So we wanted to subtract these. Right now it is subtract them, which give you already a 0, and added a 0 without the condition. The condition that have nothing to do with anything, because right now we could just plug everything into the multiply divide, and that would give us a 0. But that's it. It doesn't do anything at all. So we wanted to make sure it is activate when it is true, when there's numbers, and with that number, with our, where is it? When this push numbers for us, we wanted to go to those channel, to the pole vector, go to a plus and minus condition, and convert it back to whatever number that we wanted to tweak with. So that's what we want. So the first term, we want it to be true and not equal. Also not equal. Not equal, and we also want this one to be true. Gotta make sure. All right, we still have a 0 in our hand. Now this is where we need feedbacks from our joint. Right now it's at 0. We want numbers in it, but we don't want it to. We want 0. We want close to 0. We want it to be at 0, but we want it to convert at the condition, not equals, and get it the conditions here. I want the condition to spew the 0 for me, not the plus and minus. So what we can do, we can 0 these guys out. So once we 0 this, it should give us the exact number that is actually. So now we have information on, if you look at the information that we have for a condition, it is not the same information that we have here. So we can take those two numbers, add them, which is gonna give you a subtraction anyway, and or even close to it. So right now it is -19. So I can start with 19 and 5 and 1. With that, I can add to it. Oh. So let's pin that so we can see. So I'll give this one 19. So now it's -18 now, and this one is 5 and 1. So the best way to do this is to actually really go to a higher number. So from our condition, subtract it to 15, 25, and 1. So let's test it. So now, if we look, nothing moves. So that's exactly how we want it, and that's a great way to fix something without doing anything And if you have any if you have any rotation on your wrist, you can also use the exact same technique. But with this, we fix this without us doing the arm I can handle all over again. And with the pull vector, we use the existing pull vector, and as you can see, everything looks smooth now. All right, and that's it. A quick and easy way to fix IK FK switch issue without redoing your entire rig. If you found this tutorial helpful, don't forget to like, subscribe, and hit the bell icon. For more rigging tip, leave a comment below if you have any question or suggestion for future video. Thanks for watching, and I'll see you in the next one.